Hi, my name is Ashley, and today I will be showing you how to do a related rates problem. Question number 30, air traffic control. An airplane is flying at an altitude of 5 miles and passes directly over a radar antenna. See figure. When the plane is 10 miles away, or s equals 10, the radar detects that the distance s is changing at a rate of 240 miles per hour. What is the speed of the plane? Now, we know how this problem looks based on the figure above, but let's draw our own picture, as drawing a picture will help us gauge what we know and what the problem is asking us to find. So let's draw our antenna, just a little one, and directly above it, we'll draw our plane. Sorry, that's pretty poorly drawn, but it is 5 miles above the antenna. So this line right here, 5 miles. And then we're trying to find we need to find the length of this line, but the hypotenuse is where the plane is 10 miles away from the antenna, and it's at this point that the plane is traveling at a speed of 240 miles per hour. And 240 miles per hour is also dc dt. This will be helpful in our equations, but this is basically the rate of, or speed that the plane is traveling at this point. We're trying to find the length of that leg of the triangle, and then once we find the length, we can determine the speed at that point. I'm just going to erase that so that we have more room to write. And then we'll be using two equations for this problem, a squared plus b squared equals c squared. You probably learned this in an earlier math class. This is the Pythagorean's theorem, and essentially with it, we know if we know the lengths of two of the legs of the triangles, we can find the third using this equation. And the second one we'll be using is the derivative of this equation, or 2a dA dt plus 2b dB dt equals 2c dc dt. Well, we already know most of the variables in this equation. A is 5, as it's 5 miles in altitude. dA dt is 0, since this value will not change. The plane is going to be 5 miles above the ground the entire time. And then b and dB dt we have to find. C is 10, as that's the length of the hypotenuse, and dc dt is 240 miles per hour, as given in the equation. So we're going to set this up with 5 squared plus b squared equals 10 squared, since 10 is our hypotenuse, 5 is one of the legs, and we're looking for b. If we subtract 5 squared from one side and subtract it from the other, then we can isolate b squared and figure out what it is. So we'll do 10 squared minus 5 squared, and that will be the same as b squared equals 100 minus 25, which is equal to 75. So to isolate b, we have to take the square root of 75, and that's not a pretty number. So square root of 75 is just fine. But the square root of 75 is about 8.660 miles, which will be the length, or the x value, in our triangle. So since we know most of these values, we can plug them into our derivative equation. So we'll have 2 times 5 times 0 plus 2 times the square root of 75 times dB dt, since we're trying to find dB dt, and that's equal to 2 times 10 times 240. 5, since that is the altitude of the plane, 0, since that value is not changing. Square root of 75, since that is the length of the other leg. dB dt, which we're trying to find. 10, which is the distance between the antenna and the plane. And 240, since that's the speed of the plane at that length. So we have 0, since 2 times 5 times 0, anything times 0 is 0, plus 2 times the square root of 75 times dB dt, and that is equal to 4,800, since 2 times 10 times 240 equals 4,800. So we're going to divide the first half of the equation by 2 times the square root of 75. That way we can isolate dB dt and find its value. So we'll divide one side by 2 times the square root of 75 and do the exact same thing to the other side. dB dt equals 4,800 divided by 2 times the square root of 75. And this is your exact value, but this value can be simplified and it can be put into a decimal form, although not entirely accurate, but the decimal form will help us have a better understanding of the equation as a whole. So simplified, it's 2,400 divided by the square root of 75, and then the decimal value is approximately 277.128 miles per hour. And miles per hour are units, since we are finding the speed. The most important takeaway would have to be the two equations we used to solve this problem: a squared plus b squared equals c squared, and 2a dA dt plus 2b dB dt equals 2c dC dt. These equations are very important for solving problems like these, as if you can find these values, they can solve and answer the problem you've been given. Thank you so much for watching. I hope this video was helpful and that you have a better understanding of this problem and the context that it entails. So thank you and bye-bye.